At 19 hours, a 45-ton fighter jet sits completely still on the deck of a moving ship. There is no runway. There is no margin for error. Engines are at full power, control surfaces alive, fuel tanks full, weapons hot. 3 seconds after the launch signal is given, the aircraft is gone. Not lifted by steam, not pushed by explosives, not accelerated by distance. It is thrown into the air at 150 miles per hour by electromagnetic force, executed with precision, without shock, and without pause. This is not a test. This is not a demonstration. This is routine flight operations aboard a modern United States Navy aircraft carrier. Every day, this system launches combat aircraft faster than most civilian jets leave a runway. While the ship itself is moving, the deck is pitching, and the margin for failure is measured in feet. And here's the part most people miss. The launch isn't the weapon. The weapon is what happens next, how often it can be repeated, how fast the cycle turns, and how long it can continue without stopping. If you want clear, real-world breakdowns of how carrier strike groups operate under operational conditions, subscribe now. This channel documents systems built to function when there is no room for error. Because what you're about to see isn't a spectacle. It's deterrence, engineered, the end of steam. The United States Navy has the most complicated mobile warfighting platforms that people have ever built. These aren't ships in the usual sense. They are self-contained warfare networks that can move over 100,000 tons, carry 90 planes, and support thousands of people without needing help from shore. A contemporary U.S. aircraft carrier is a movable airbase, a floating city, and a strategic command center, all in one. At all times, at least one carrier strike group is deployed forward. This means that they are covering sea lanes, keeping an eye on areas that are being fought over, and giving National Command Authority alternatives for quick responses. This is not a symbolic presence. This is active deterrence. The carrier's capacity to launch planes quickly, repeatedly, and without limits is what makes that deterrence work. And that skill has changed the most in the history of naval aviation, without anyone noticing. EMALS, electromagnetic dominance. For a long time, steam catapults were the main way to launch planes from carriers. Massive pistons powered by pressurized steam threw planes forward with a lot of force. Works, but not very well. Angry. Needs a lot of maintenance, not much. Steam systems put a lot of stress on airframes, made it hard to change the cargo, used quite a lot of labor, and set stringent limits on how many sorties could be generated. That time has passed. Steam has been replaced with something very different on America's newest supercarriers. Electromagnetism. What EMALS does to change everything. The EMALS, or Electromagnetic Aircraft Launch System, is not an update. This is a reset. A 300-foot linear induction motor operates along the catapult track underneath the flight deck. Coils of copper, converters of power, modules for storing energy. Digital control systems keep everything in harmony. When the launch officer gives the go-ahead, stored electrical energy fills the system. Magnetic fields come together right away. A shuttle that is magnetically linked to the plane is pushed forward with a precise, computer-controlled force. It takes the plane from 0 to flying speed in about 2.5 seconds. No shock loading, no impulse that breaks frames, no violence with machines, just controlled acceleration set to the specific weight, shape, and mission profile of the plane. The real weapon is sortie generation. Before needing extensive repairs, traditional steam catapults could launch an average of 4,000 times. It is possible to launch EMALS 20,000 times before it needs to be serviced. That lasts 5 times longer. It needs 30% fewer people, uses 30% less energy every launch, and can handle more sorties without as many mechanical problems. But the true benefit is in how it works. Without having to redesign or make any compromises, EMALS lets ships launch bigger and lighter aircraft as well as unmanned devices. It makes it possible for platforms that aren't yet in use, and it gets rid of the roadblocks that used to slow down the air wing. In modern warfare, speed is key. Getting better in extreme conditions. Hollywood shows one plane taking off every few minutes. In real life, things are much more forceful. During surge operations, a single Nimitz-class or Ford-class carrier may launch up to 125 strike sorties in a single day. From one moving ship, that's 125 combat missions. Launched, recovered, refueled, rearmed, and relaunched. With precision-guided weapons, each aircraft can hit more than one target during a single mission. In terms of total firepower, one carrier may deliver more than many national air forces combined. This is why enemies are always watching carriers move. This is why their presence changes whole areas. And launch is only one part of the puzzle. Electromagnetic recovery. Landing on a carrier is the hardest thing to do in military aviation. A modern fighter jet flies at a speed of 150 miles per hour. The deck length that can be used is less than 500 feet. The ship is on the move. The deck is moving. Margins are measured in feet. If you miss the arresting cable by a few seconds, the plane goes overboard. Advanced arresting gear takes over here. Flight deck. Chaos under control. 2 nuclear reactors are hidden deep inside the hull of every modern U.S. aircraft carrier. These are A-1B reactors on Ford-class ships that make more than 700 megawatts of power. That's enough electricity to power a city of 700,000 people for 25 years without needing to refuel. This power makes everything work. Catapults for EMALS, advanced gear for stopping, radar systems that can see far away, suites for electronic warfare, desalination plants that make 400,000 gallons of clean water every day. The carrier doesn't have a restriction on energy. It has a lot of energy. Weapons, elevators, hidden speed. The flight deck of the ship covers 4.5 acres. Planes are always moving. Steel melts when jet exhaust hits it. The propellers, rotors, and blast deflectors all work at the same time. People often say that it is the most dangerous location to work on Earth, but it keeps working all the time. The reason is dance. Each crew member has a jersey that is a different color. Yellow tells planes where to go. Red takes care of weapons. Defensive layers. There are thousands of pounds of weapons stored in reinforced magazines underneath the deck. Moving weaponry to the top of older carriers caused problems. That limit is no longer there on Ford-class carriers. Advanced weapons elevators use electromagnetic linear motors that can raise 24,000 pounds of explosives at a rate of 150 feet per minute. 2 times the amount, faster by 50%. Their positioning keeps the deck from being crowded and lets operations run at a high speed for a long time. Beyond war, a carrier is never alone. It sails in the middle of a carrier strike group, which is covered by destroyers, cruisers, submarines, and planes that form layers of defense that stretch for hundreds of miles. If threats break through that outer ring, the carrier has CIWS, rolling airframe missiles, and electronic warfare weapons to mess up command, targeting, and guiding linkages. A lot of this skill is still secret, and that's on purpose. Living in a city made of steel, aircraft carriers are not only used for combat, but they are also used for humanitarian response. During calamities, they bring fresh water, medical care, the capacity to airlift people, and power generation. When shore infrastructure fell apart, carriers gave timely help after the 2004 Indian Ocean tsunami and the 2010 earthquake in Haiti. This 2-part role is what defines modern American naval power, the machine that keeps people, food, and water alive. A modern carrier can hold about 3,000 people from the ship's company. When the air wing is on board, that number goes up to about 5,000. This is a group of people who move around and make their own electricity, water, logistics, and medical care. Berthing compartments are built to work well. Sailors sleep in stacked racks that include curtains for privacy, lighting, and storage. Medical ability. The galley serves over 18,000 meals every day. Nuclear-powered desalination makes water on board. Medical spaces look like miniature hospitals and can be used for surgery, trauma response, and long-term care. This medical capacity becomes crucial during flight deck accidents or humanitarian missions. The real coolest thing. It's not the launch itself that is the coolest thing. It's time to start over. Airplanes can land, refuel, rearm, move to a new location, and take off again. Purple shirts give energy. Red shirts carry weaponry. Green shirts fix catapults. Yellow shirts move planes. Weapons elevators move 24,000 pounds at a speed of 150 feet per minute. The deck never stops moving. That is the true weapon. Why 125 sorties makes the map different. If a carrier can launch 125 strike sorties in a single day, it can become a moving airbase that can affect an entire region without needing land bases. It gives a presence without making things worse, and a deterrent without making things worse. That number changes how decisions are made. Defense. The bubble you can't see. Any enemy that wants to attack a carrier must get past layered detection, interception, and deception. Escort ships fight from a considerable distance. CIWS shoots 4,500 rounds every minute. RAM stops a lot of dangers. Electronic warfare makes sensors blind. The visible deck is just the top. War with electromagnetic weapons. Spectrum supremacy is the future of naval fighting. Attacks like jamming, disruption, and deception mess with the enemy's decision-making process. A missile is only harmful if it can hit what it's aiming at. Power gives you control. Control wins fights. The reality of the competition. At 0724 hours. In a struggle between great powers, carriers are judged by what they can handle. Your model makes the difference clear. U.S. carriers use a lot of different technologies like nuclear power, electromagnetic launch, advanced arresting systems, integrated defensive layers, and high-tempo sortie generation. China is building up its carrier capacity, but your model says they still use a lot of ski-jump launch technologies, which limit payload and range compared to catapult launch. The engine of the economy. Each Ford-class carrier costs about $13 billion and is part of a national industrial network of thousands of suppliers. Carrier programs keep advanced manufacturing, nuclear engineering, software development, and material science going for decades. The mission logic. Why it's important. Aircraft carriers aren't there to look good in port. They exist to quickly make choices. When things go wrong, planners ask a simple question. Where are the trucks? Because a carrier strike group can arrive without being based in the host country. Keep air operations going from the sea. Give the ability to respond to humanitarian needs. Change the pressure without making things worse right away. Show apparent deterrence with real power. The strategic value is not just a theory. It happens right away. There isn't just one system on a U.S. aircraft carrier that is the coolest. It's the joining together. Launch with electromagnetic force. Endurance of nuclear power. High-speed sortie generating. Defense in layers. Floating city that makes 400,000 gallons of water per day and is ready for battle. That's how the U.S. Navy usually works. The mission goes on. The Navy Recon will be keeping an eye on everything. Please like the video, subscribe, and turn on alerts.